of the stack. So first of all, we will discuss array based implementation of the stack. So we are going to look at the stack as a ADT, abstract data type. Address data is nothing but the information about the element and address of the next node in the list. So these are the operations performed on the stack. Push operation. For that, we need to pass the element that you want to push on the top of the stack. When we want to remove the element from the stack, only we have to mention pop operation. We don't have to mention element that we want to remove. The one which was lastly inserted will get removed if we call pop operation. Now peak operation, it is also called as top operation. So peak operation returns what is the element. It shows you what is the element on the top. It means it displays you what is the lastly inserted element. And isEmpty function will check if the stack is empty. So isEmpty function will return true or false. If stack is empty, it will return true, or else it will return false. The next concept is stack overflow. When the stack is having full capacity of their elements, and when there is no space to insert the element into the stack, then it is called as stack overflow. The stack underflow, if the stack is empty and we want to delete the element, so we cannot delete from the empty stack. So in that situation, it is called as stack underflow. So at the time of inserting the new element into the stack, we need to check stack overflow. And at the time of deletion, we need to check stack underflow. So this is the implementation of stack using array. This is an array. Max stack means maximum how many elements we can have. And top means index of lastly inserted element. Now see here, this is the implementation aspect. So we need to declare the structure stack. In that we have the array where we are going to store the element. So size means how many elements we want to store in that stack, and top means it is the index of lastly inserted element in this array A. So init stack will make the stack empty. That is the purpose of init stack. We want to make the stack empty. So how to make the stack empty? By making top as -1. We have to make the stack empty. Push operation will push an item into the stack, and pop operation will delete an item from the stack. So init stack, push and pop, these are the three operations. Now see here, in init operation, we have to pass this address of this structure. Why we have to pass the address of this structure? Because changes done in this structure needs to be reflected in the main. So whatever changes are done in A and top, that must be reflected in main. So we need to pass the address of the structure. So S arrow top is set to -1. So initially when the stack is empty, top is set to -1. And this is the push operation. To the push operation, we have to pass address of the stack and item. Here we check stack is full first. How to check stack is full? When top is equal to size -1, then stack is full and return. If it is not full, then increment the top by 1, and at that top position, insert the item. So we have to insert the item in A. So suppose A is the array. So here by mistake it is small a, it should be capital A. A is the array in which we insert the element item. Then pop operation. Pop operation will remove the data from the stack, top lastly inserted element from the stack. So S is the pointer to the stack, pointer to the structure stack. And first of all, we check if it is empty. So how to check if it is empty? When top is equal to -1, then stack is empty. So return stack is empty, and If it is not empty, means it is having at least one or more number of elements. So whichever is the top element, we take it in the data and then we decrement the top by -1. So top is the inside the structure. So that's why S arrow, S is the pointer to the structure. So that's why we use convention S arrow top -1 and return data. And this, in this way, we can call these functions push and pop from the main. So remember, we have to pass the address to the structure stack. So I have written the program. So let us declare the size. So hash define size is set to 5. Size is set to 5. And here, since it is the capital A, so here I make use of capital A. Here also capital A is mentioned. Now, this is the init stack, means to make the stack. Then push operation, wherein we put the element into the stack, and pop operation, lastly inserted element is deleted from the stack. So push doesn't return any element. Init stack also doesn't return any element. Pop returns the lastly deleted element from the stack. So again, I write one function, display stack. So which will display all the elements into the stack. For I is equal I is the index. So for I is equal to 0, I less than size, top. So it is S arrow. So S arrow top less than equal to top. So remember, top is the index of lastly inserted element. So from index 0 to top, you want to display all the elements into the stack. So I plus plus. This is the for loop. So printf so we have to display all the elements into the stack at index I. So it is S arrow A, and index of A is I. So for I is equal to 0, A of 0 is displayed till I becomes top. All the elements into the stack are displayed in this way. So first we need to create the variable of the structure. So this is a structure variable. First of all, we need to create a variable of the structure. So struct stack S. Suppose I call it as st. St is the variable, and then after creating the variable, Yeah, so first of all, we have to create a variable of this stack, structure stack. In that variable, in that st, there will be a array A and top. Now we have to pass this st to init stack, then we have to call push function and then pop function and display stack. So first of all, we have to initialize the stack, means we have to make it empty. So let us call the init function, init stack, and to that we have to pass pointer to structure stack variable. You have to pass pointer to structure stack variable. So address of st. So structure stack variable is st, and whose address we have to pass, because here it is pointer. Init stack is the pointer, s is the pointer to struct stack. S should hold the address of variable of type struct stack. So that's why we have passed address of st, because it is collected in pointer init stack. So in init stack, this it is initialized to top is initialized to -1, and then after that I can call this push function and pop function. So push function, instead of s we have to write st, because I have used st here. And first element push is 10, then 20, 30, 40, and then after that pop function is performed, means which is the lastly inserted element, 40. So 40 is popped. So that 40 is stored in I. So let me declare this I and display this I. So printf popped element is I. So popped element is I. And then you want to display stack. You want to display stack. For display stack, actually modification is not performed. So we can make it s without making pointer. We can write it s, and here you can use dot operation, because changes are not done in display stack, neither in top or neither in A. So no need to pass the address. So pass the value. So s pass the variable, and s dot top and s dot A. So only pass the variable st. So it will display all the elements in the stack. So let us compile this and run this program. Yeah. So popped element is 40 and all the elements are 10, 20, 30. So let us after pushing display, call the display stack. So printf contents of stack are so after every push, let us display contents of stack so that one can understand easily. So perform push operation on the stack and display the contents of the stack. Then again push 20 and display the contents of the stack. Then push 30, display the contents of the stack. So in this way, every time you push, display the contents of the stack. So here after popped element, you have to display popped element is. So let us see, and yeah, so after pushing 10, after inserting 10, contents of the stacks are 10. Then 20 is inserted and then contents of stacks are 10 and 20. So 20 is lastly inserted. Then 30 is inserted, then contents of the stacks are 10, 20, 30. Then 40 is inserted, then contents of the stacks are 10, 20, 30, 40. And after that 40 is removed, pop operation is performed. Now you can see here pop operation is performed after inserting 40. So here after executing the pop operation, popped element is 40. So 40 is removed. So what remains in the stack now? After removing 40, 10, 20, 30. So contents of stacks are 10, 20, 30. So this is the implementation of this stack. So once again I repeat, what are the implementation of so the size of the stack is 5. And then init stack, in init stack we have to make the stack empty initially. So how to make the stack empty initially? So to store -1 in the top. And then push function. In push function, first of all we have to check whether the stack is full. How to check stack is full? So s arrow top is equal to size -1 and stack is full, it is written. And then if it is not full, then we have to make changes in top, increment the top by 1, and then at that index insert the item. Similarly in pop, first of all we have to check stack is empty. So how to check stack is empty? Stack arrow top is equal to -1. If it is -1, then stack is empty. If it is not empty, then whatever top element is there, get it into the data and decrement the top by -1 and return data. And display stack will display all the elements from index 0 to top. So this is the implementation of this stack. So I will share this program on the team. Okay. So next thing, this is the implementation of stack using linked list. So just now we have discussed implementation of stack using array. Now let us insert 5 elements. So right now we have inserted 4 elements. So let us insert 5 elements, 10, 20, 30, 40 and 50. So one more element I inserted 50, and after 50 insert one more element. Actually the size is 5 only. Let us see what if we insert more than 5 elements. So it will take 10, 20, 30, 40, 50. After that, when you insert 60, so more than 5 elements, it will show error that stack is full and it will do nothing. And then when it pops, it will pop the lastly inserted element and it will display the content of the stack. So let us execute this program. Yeah, so you can see 10, 20, 30, 40, 50. After that, it has shown the error stack is full. When we want to insert the 60, it has shown the error stack is full, and then it has displayed all the contents, means 10, 20, 30, 40, 50. Only 5 elements are there. Now right now stack is full. Now lastly inserted element is 50. So it has popped a 50, means it has removed 50, and after removing 50, the remaining elements are 10, 20, 30, 40. So this is how we need to check the stack is full. Then initially only when we perform the pop operation. So before inserting 10, first of all, if we perform pop operation, let us see what happens. Since there is no element into the stack, first of all, if we perform pop operation, let us see what happens. So it should return -1. Nothing is stopped. Okay. So you can see when you perform pop operation at the beginning, because stack is empty, so it shows the message stack is empty, popped element is -1 because there is nothing into the stack. And then we push all the stack and then it shows the content. So this shows that when the stack is empty and when you perform pop operation, it should show the message stack is empty. So this is how we should implement the stack. So this is the linked list implementation of the stack. So as usual, struct node, and this is the link or next. Some textbook follows the convention of next, some textbook follows the convention of link. Both are same. Similarly, push and pop operations are there. This is insert and this is delete operation. So del stack means it will remove all the elements from the stack. It will make it empty. So why double pointer is pass? Because we are making the changes in the first node. So push function is insert at the beginning and pop function is deletion from the beginning. So we need to do the changes in the pointer to node. So that's why we have to pass double pointer. So let us copy and make this function. So let us create new project. So create a new project. Stack using list. So copy all this. So struct node link push pop function and delete stack. And let us copy push function. See here, first allocate the node using malloc and store the address in temp. If temp is 0, stack is full. If temp is null, means if malloc fails to allocate the memory, then temp is null. It returns 0. So in that situation, stack is full. If malloc has allocated the element, then temp arrow data store that item in new node, and temp arrow link is equal to make it to point to first node. So let me show you the logic. Now see here. Suppose this is S pointer to first node. So these are suppose some nodes in the stack. Suppose it is 10 and 20. And suppose you want to insert 30. Suppose you want to insert new element 30 and whose address is stored in temp. And this element should get inserted here. So insert at beginning. So this is the case of insert at beginning. So 30 is inserted lastly. So 30 should get deleted first. So it is insert at beginning and delete at beginning. So how to insert 30 here? First make this to point to this node. And that address is present in S, and S address is present in top. So address of S is present in top. So here first store star top here. So this node's address will be stored here. So this link is established, and make top to point to yes, make S to point to this node. So but yes address is present in top. So how to access yes? Star top. So that is what is shown over here. So temp arrow data is equal to item. Temp arrow link is equal to star top. This is what I stored over here. Temp arrow link is equal to star top. See, temp arrow link. This is temp arrow link is equal to star top. Star top. Top is what? Top is address of S. So S is pointed to first node. Star top is address of S, and star top means S. So indirectly S means what? Address of first node. So here we have to store S, but we have only top. So what is top? Address of S. So how to access S here? How to store S here? So write star top S. So that's why. So temp arrow link is equal to star top, and star top is equal to temp. So indirectly it is temp arrow link is equal to S, and S is set to temp. So this is push operation. Similarly, pop operation. First check whether top is null. Star top means S. Indirectly it is S. S means address of first node. Address of first node in the stack. If stack is empty, then return. Then if it's not empty, then take the top in temp, and then take the data in item, and then make top to point to next node. Make top to point to second node, and then free temp and return item. So let us copy this function, push function. And then write the top function, pop function. So push at pop functions are written, and let us write display function. struct node star current. So for traversing purpose, we make use of current function, current variable. So in display, you have to pass address means address of the first node. So struct node star t. Yes, write it is t. So first store t here in current. Make current to point to first node, and address of first node is stored in t. So set current to point to the first node and test while it has reached to the last node. Go on displaying all the elements while current not equal to null. While current not equal to null, display data in the stack. Current arrow data, and next current is current arrow link. Sometimes you can call it as a next, or sometimes you can call it as a link. So both the conventions can be followed. So here, while current is not equal to null, so when current points to the last node and when it makes last node's next point, so then it becomes null. So it will display the last node data, and after that current become null. Now let me explain this concept over here. See, this is suppose this is the stack. Suppose this is the stack with the 3 nodes. So initially make current to point to this node. So suppose it is 10, 20, 30. So it will display current arrow data. So it will display 10. Then make current, new current is equal to current arrow this link. So this is suppose 1000. This is suppose 2000. This is suppose 3000. So current is equal to current arrow link. Link means next this. So what will happen? Current arrow link is 2000 here. So new current will be current arrow link. So new current will be 2000. So here current will point to this. Then it will display data here. Then next current will be current arrow link. So this current arrow link will be 3000. Current now next current will be 3000. Now this current will point to this. Now here current arrow data is 30. So here it is null now. Now after displaying 30, we execute this statement. Current is equal to current arrow link. So current arrow link is 0. So next current becomes 0. Current now becomes 0. So when current becomes 0, current is null. Current is null. So when current is null, all the nodes are displayed and it will stop. That is the while loop condition. So that is while loop condition. Current not equal to null, it will display the data. When current becomes equal to null, it will stop displaying. So as long as current is having pointer, it is pointing to the node and it will display the data of that node. The moment current holds null means after displaying last node contents, current becomes null. So the moment current becomes null, this while loop becomes false and it will come out of this while loop. And we have displayed all the uh, all the nodes contents. So this is a push operation, and this is a pop operation, and this is display stack. So let us call same thing from this. Let's call push pop. So let us stack. Sorry, struct node. Let us declare a pointer to the struct node. Let us declare S to be the pointer to the struct node. S is the pointer to the struct node, that is, it holds the address of the first element. This is the address of the first element. And the push will pass address of this S. So that is stored in start top. So top holds address of S. Start holds address of S. So address of S is passed in top, because pointer to the first node changes every time. So push function means insert at beginning, and pop function means delete from the beginning. So when you insert at beginning and delete at beginning, address of the first node changes. So in this case, address of first node is S. So it changes. So initially make it null. Initially make it null. Initially make it null, and then push 10, 20, 30, 40. And then after every insertion, call display stack. So in that case, only pass S. Single pointer is passed, because in display changes are not done. Single pointer is passed. Display stack. Here we display stack contents are it will display contents of the stack. So display stack, after every push, display the contents of the stack, and after pop also display the contents of the stack, and display popped element. The popped element is I. Now in this way we have implemented push, pop, and display stack. And here, by making S is equal to null, we have created the empty stack. S is the pointer to the first node. So we have to declare I here. It is printf. Okay, now you can see here after inserting 10, contents of stack contents are 10. After inserting 20, stack contents are 10 and 20. So while displaying, it displays 20 first because we are displaying from first node. So first node is 20, next node is 10, but 20 is the lastly inserted element. Then first node is 30, 20, then 10. But lastly inserted element is 30 because insert at beginning. This is the lastly inserted. Firstly inserted is 10, then 20, then 30. Then 40, 10, 30, 20, 10, and so on. Then after that, we perform the pop operation. 40 is deleted. Remaining elements are 10, 30, 20, and 10. So this is the implementation of the stack using linked list. So this also program will be shared to you for your reference. So there are many methods of implementing it. Some textbooks call this as a link, some textbook call this as next. So whatever convention you find suitable, you can implement. Okay, now we are going to discuss applications of this stack. Now there are many applications of this stack. In mobiles also stack is used when you send the messages in the WhatsApp. So whatever is lastly sent message, you get it on the top and so on. So most visible applications of this stack is string reversal. Now, if you want to reverse the string, so how one can reverse the string? Let me show it. Suppose the string is the name of the string is A, B, C. So what is the reverse of this string? C, B, A. You want to reverse the string. So how can you reverse the string? So read the character and push it into the stack. So this is the character stack. So read A and push it into the stack. Then read B, push it into the stack. And read C, push it into the stack. And then display the stack from top to bottom. So when you display the stack from top to bottom, so it will be C, B, A. So it will be C, B, A. So this is how stack is used in string reversal. Then next application is parenthesis checking. So the expression is having many parentheses. We have to check whether that expression is having balanced parentheses. So let me explain once again. Now, when we write an expression like this, bracket 2 plus again bracket 3 minus 6 bracket and again one bracket. So these are the two opening parentheses and these are the two closing parentheses. Is for every opening parenthesis there should be closing parenthesis. So this expression is of balanced parenthesis. Means for every opening parenthesis there is a closing parenthesis. Now here this is not the case of the balanced parenthesis. 3 minus 6. This is not a balanced parenthesis because there are two opening parentheses and there is only one closing parenthesis. Now, how can we check if the expression is having balanced parentheses? Now we can do this using stack. Now see how we can do this stack. Now read the character by character in this expression. So store this expression in the array. So store this expression in the array. So every character is stored in the array. So this is the array of character. Now first character is opening parenthesis, second character is 2, third this 2 is the character, not a digit. 2 as a character, then plus as a character, then opening parenthesis 3 minus 6 character closing parenthesis character closing parenthesis. Now read this character, and if it is only opening parenthesis, then push it onto the stack. Then this is the character stack. If it is opening parenthesis, push it onto the stack. Then next character is 2. It is other than opening parenthesis, so do nothing. If it is other than opening parenthesis, do nothing. Then again read next character. This is plus. It is not opening parenthesis, so do nothing. Now again, this is the opening parenthesis. When it is opening parenthesis, push it onto the stack. So again 3 do nothing, minus do nothing, 6 do nothing. Now here it is closing parenthesis. So when you read closing parenthesis, now check whether the top of the stack is opening parenthesis. When there is a closing parenthesis, check on the top of the stack if it is the opening parenthesis. If it is opening parenthesis, remove, perform the pop operation. If the character you read is the closing parenthesis and the top of the stack is opening parenthesis, then perform pop operation. When you perform pop operation, this is removed. This is removed. So perform pop operation. Now this is removed. So remaining is only this. Now here, next character is again closing parenthesis. Again, when you read the closing parenthesis, check whether the top of the stack is having opening parenthesis. So again, top of the stack is having opening parenthesis. In that situation, again perform pop operation. So when you perform pop operation, this will get removed. This will get removed. Now nothing is remaining here. Now nothing is remaining here. Nothing is remaining to be read, and the stack is empty. When nothing is remaining to be read and stack is empty, then the given expression is having balanced parenthesis. Now look at this case. Now the first character is opening parenthesis. Now push it onto the stack. Now 2 do nothing, plus do nothing. Then again opening parenthesis, push it onto the stack. Then 3 do nothing, minus do nothing, 6 do nothing. Now closing parenthesis. When you read the closing parenthesis, check if the top of the stack is opening parenthesis. Check if the top of the stack is opening parenthesis. If it is opening parenthesis, remove this, perform pop operation. Now when you perform pop operation, this will get removed. Now when nothing remains, when no parenthesis, no character remains, now it should be empty. Stack should be empty, but stack is not empty. Stack is having single opening parenthesis, which means that there is no balance parenthesis corresponding to this opening parenthesis. Means there is no balance parenthesis corresponding to this opening parenthesis. So this expression is not balanced. So in this way, we can check the concept of balanced parenthesis using stack. So same thing is explained over here. So okay. So today we discuss